Hello, my name is Luis Salazar, and I'll be going over 3 of these 4 problems. So we're just gonna go in order. We're gonna solve number 1, number 2, and number 3. So the first one, it says determine if Rolle's theorem applies to the following function on a given interval. If so, find the points that are guaranteed to exist by Rolle's theorem. So essentially, Rolle's theorem is saying if we plug in this 0 and this 1 for x, if they both get 0, then the Rolle's theorem applies. So we're just going to test that out right now. So we're going to plug in 0. So that's 0 times 0 minus 1 squared. And if you plug that into the calculator, you get 0. So now we have to try if 1 gives us 0. That's a 1, not a 7. And this, if you plug it into the calculator, gives you 0 as well. So here it's telling us that Rolle's theorem applies because they're both equal to 0. Now, all we have to do next is we're going to find the derivative of our original function. So that is just x times x minus 1 squared. So our f of x is equal to x, and then our g of x, that's supposed to be a g, is equal to x minus 1 squared. So now we have to find the derivative of f of x, which is just x, so that's 1, and then the derivative of g of x, which is equal to 2 times x minus 1. So now, using the product rule, we just add the f prime times g of x plus f of x times g prime of x. So that would just be x minus 1 squared plus x times 2 times x minus 1. And then once you found the derivative, we're going to set it equal to 0, because essentially what we're looking for is what the x's are. So x minus 1 squared is essentially just let's solve this. X minus 1 plus x times 2x minus 2. So now this x gives us x squared, and then minus x plus 1 plus 2x squared minus 2x. This x squared plus the 2x gives us 3x squared. And then we're going to cross these out just so we don't get confused. This negative x and this other negative x is going to give us 2x. And then we also have a minus 2x. Oh, this is negative 2x. Minus 2x will give us negative 4x. And then we just have plus 1 left over. And essentially this is all equal to 0. So now we have to use the x method to factor. So we're going to do 3 times 1 gives us 3 at the bottom, and then negative 4 on top. So we have to find two numbers that multiply to give us 3 and add up to give us negative 4. So that would essentially just be negative 3 and negative 1. Negative 1 times negative 3 would give us positive 3. Negative 1 plus negative 3 would give us negative 4. So this is 3x squared minus 3x minus 1x plus 1. This is all equal to 0 again. So now we're going to split this up like this. Don't forget this negative. And then we're going to factor again, keep factoring. So this we can factor out at 3x, leaving us with x minus 1. And over here we can factor out a negative 1, leaving us with x minus 1 again. So this is 3x minus 1 times x minus 1. And this is equal to 0. So this is 3x minus 1 equal to 0. Add 1 to move it to the other side to get x by itself. 3x is equal to 1 divided by 3. X is equal to 1/3. Yep. And then over here, x minus 1, set this equal to 0. Add 1. And then x is equal to 1. So here we have two answers. 1/3 and 1. But here we can't forget to look at the interval that we were given, and that was 0 to 1. So this one is not included in the interval. So our answer would be 1 over 3. And if we were to plug this into the original function and to get a point on the graph, we would essentially get 1/3 over 4 over 27. And that is our answer for number 1. Now I have to erase my work so that we can go to the next problem. Okay, so it says number 2 says determine if mean value theorem applies to the following function on the given interval. If so, find the points that are guaranteed to exist. So essentially this is kind of similar to roles, but not really, because you're going to be using these again. Instead of getting 0, we're going to find points. So we're going to find an x and a y. So we're going to plug in our -1 into the equation. So it'll be 7 minus -1 squared, and that would give us 6. Yes, that would give us 6. So that's our y. So we know our point is -1, 6. Yes. And then now we have our next one, which is 2. Plug into, and that'll give us 7 minus 2 squared, and that would give us 3. So this is 2 and 3. So now we have our x1 and y1 and our x2 and y2. So we have to remember the formula y2 minus y1 over x2 minus x1. So we're going to use y1, which is 3, minus y2 minus y1, which is our 6, over x2, which is our 2, minus our x1. And then we're going to set this equal to the derivative of the original function, which is just be -2x, because the 7 is a constant giving us a 0 when finding the derivative, and the negative x squared brings the 2 to the front. 2 minus 1 would give us 1, so it would just be -2x. So now 3 minus 6 gives us -3. This changes, would give us just 3, and it's equal to -2x. So this is essentially -1 is equal to -2x divided by -2 to get this x by itself, leaving us with x is equal to 1/2. And that is our answer. And this does apply, it is in the given interval, so that is correct. And if you want to find this as a point, you would put into the original function, giving us 1/2 for our x and 27 over 4 for our y. So this is our answer. Now I'm going to erase for the last problem, which isn't going to take long. Okay, so it says use L'Hopital's rule to find the following limit. So this rule is essentially telling us that if we plug in this number right here, and if we get a 0 on top and 0 on the bottom, we essentially are going to have to find the derivative, plug that one back in, and if it's a 0, 0, keep finding the derivative until you get an answer, until you get something that does not give you 0 over 0. So that's essentially what we're going to be doing. So I've already done this, and if you can just plug in this one for each x, and you'll find out that you'll get 0 over 0. And you can also just look at the denominator is x minus 1, so essentially 1 minus 1, giving a 0 in the denominator, letting us know that it's already going to be 0 over 0 without having to plug in the numerator. So first, we're going to have to find the derivative of this, so that would just be x to the power 4 would give us 4x cubed, and then x cubed would give us 3x squared, and then 2x would just give us 2x, and 2 would just give us 2, not 2x, and then d2 would just give us 0 because it's a constant, and we don't really need to add the constant, and then x, the derivative of x is 1, and the derivative of -1 is just 0. So now we're going to plug in this 1, so that'd be 4, 1 cubed, minus 3, 1 squared minus 2 all over 1. And if we plug this into the calculator, we end up getting -1 as our answer. That is our answer, -1. If this were to give us 0, again, we would just find the derivative of this and just keep going until we get a number that's not 0. But yeah, number 1, -1 is our answer. And those are 3 of these problems solved. Yeah, goodbye.